We thought it would be time to give you an update on how a wind tunnel works for those of you who are interested in how a wind tunnel works. Wind tunnels have been around for a long time now, more than 100 years. The first one was built by Gustav Eiffel in about 1906, and the design of wind tunnels can vary quite a lot. For example, you could use a bit of a bell mouth, if you like, a trumpet, to allow air to come into a working section, then have a working section, a little bit of a diffuser, and then some fans. And then you can put that whole package just like that into a building and allow the air to find its own way back around the building and back through the working section again. It's a system that's low cost to build, but no Formula One team uses a facility like that, basically because it's quite expensive to run. So it's cheap to build, but expensive to run. And one of the reasons that we use what we call a closed circuit, a circuit that takes the air around a loop, is so that we can continue to use some of the energy we put into the air to drive it around the wind tunnel. We reuse that air. It's just a more efficient way of using the electricity that we use to drive the air around the wind tunnel. And the wind tunnel is a sort of an odd looking shape, if you like. We have our fan almost opposite the working section in our circuit. The fan, we have a rather large fan. It's about 3 megawatts of power that allows us to run to about 80 meters a second. The fan is housed on a very large block of concrete. We call it a seismic mass. And the reason is that if you didn't have it mounted on something very, very solid, it would create like a seismic event, an earthquake, because you're using so much power. And no matter how good a job you do with your fan, it'll never be perfectly balanced. It'll be reasonably well balanced, but it's never going to be perfect. So you mount it on a very large mass, and the seismic mass is then mounted on an even bigger mass via effectively, literally, springs and dampers. If you physically go into our wind tunnel and you look at where the fan is mounted, you literally see springs supporting the minor seismic mass. And then the mounting, the foundation for the fan is then a separate foundation from the rest of the building. It sinks down into the ground a very long way, and there's a soft connection between it and the rest of the building. It doesn't stop, it's not large, it's relatively small. The vibrations are quite small, but there are vibrations there that you don't want to go into your building, and in particular you don't want fan vibrations to shake your model, so you have a separate foundation. So just the science of building a wind tunnel in itself is really, it's interesting as if you're an engineer. It's just an interesting science. And then going a little bit more into the air side, the aerodynamic side of the design of a wind tunnel, if we start with the fan, we have the fan, it blows the air along, it creates turbulence, if you like. A fan will tend to take the air and make it rotate because you're rotating the fan blade. So the fan blades are designed to push the air in one direction, but they add some rotation. So after the fan, we have, if you like, anti-rotation vanes that try to then re-straighten the flow. We then also expand the air. You see the airline looks like from the fan it's expanding almost all the way to the working section, then it contracts for the working section, and then after the working section it expands again. And the main reason for that is the efficiency of the use of the air. It takes more energy. If you kept the working section size all the same all the way around the airline, then you actually have a higher build-up of boundary layer. The friction of the air on the walls of the wind tunnel is higher if the velocity is higher. And aerodynamic forces increase with the square of speed, so the friction really is much higher at high speed. So if you gently slow the air down as you send it around the airline, you slightly reduce the losses you get as you send the air around your facility. It means your airline perhaps has to be a little bit larger, so again it increases the cost of building the wind tunnel, but it does then use energy more efficiently. But that's not the only reason. We also have to manage to take the energy we put into the air. So the energy we put into the air, we have a 3 megawatt fan. If you're driving at full speed, those 3 megawatts effectively generate motion. You call it Brownian motion. It generates excitement between the molecules in the airline, and that energy becomes heat. So we heat the air up as we drive it forward. We have to take that heat out of our airline. I'm giving the game away now. I'm going to ruin the future of aerodynamics.